welcome to the first GMEC Challenge lesson, Greater Manchester Engineering Challenge. But don't panic if you're not tuning in from Manchester. It doesn't matter, you can tune in from wherever you are in the country or indeed the world. My name is Dr. John Chippendall, also known as DrChips, and I'm a primary school teacher in Manchester, but I'm also an ex-engineer. I used to be an aerospace engineer, so I spent lots of time thinking about the way aircraft fly and thinking about how we could get them to fly better, making them more manoeuvrable. Now today, in this session, we're going to be learning about civil engineers. We're going to start to think like a civil engineer. We're going to understand a little bit about what civil engineers do and how the thinking skills that they need to tackle the challenges that they do. So let's start by a nice little activity called Odd One Out. Now I'm going to show you 3 pictures, and what you have to do is think of a reason to link 2 of them to make the third one the odd one out. So I'll give you an example. Let's go to these pictures here. So these are the 3 pictures. We've got a picture of 2 buildings, a picture of a school bus, and then a picture of someone brushing their teeth. So what's the odd one out and why? Well, let me have a go at this. So maybe I could say that the brushing your teeth is the odd one out because the school bus and the building are both have metal involved in the construction of them. So they're things which are made involving metal and plastics and rubbers and stuff, and the teeth one doesn't have that. So there we go. That's my first example. I can make the toothbrush one the odd one out. Or I might say, for example, the school bus is the odd one out because that operates outside, whereas you do your teeth inside, and when you're at an office building, you're inside as well. There's 2 examples. So what I'm going to do now is give you some time to think up a reason to make one of those the odd one out by linking the other 2. Over to you. Okay, so how did you get on? Did you come up with lots of different ideas here? Because there's no real right or wrong here, but I must tell you actually that today I put this in as a little bit of a tease because there isn't really an odd one out when we think about things from the perspective of civil engineers, because all of these pictures actually depict things which are the result of civil engineers' work. So civil engineers create buildings, whether that be they design and construct them, whether that be hospitals or schools or office blocks. They also are responsible for all the roads which connect different parts of cities or cities together themselves. And they're even responsible for the distribution of all of the water that we need in our houses to do things like clean our teeth in the morning. Civil engineers are responsible for that water getting to your home. They're also responsible for water leaving your home and going into sewage. So that's why we can flush away whatever we might leave in the toilet in the morning. Anyway, on that lovely note, let's come back to me there. So, civil engineers, really important people. And what better way than to learn a little bit more about civil engineers than to speak to someone who works for probably one of the biggest civil engineering organisations in the world, Balfour Beatty. So we're going to go now. I caught up with Andrea Holt from Balfour Beatty earlier today. So let's go to that clip now where I speak to Andrea a little bit more about what civil engineers do, why they're so important, and some of the challenges that they are continuing to tackle at the moment. So watch this and I'll be back in a second. Good morning, Andrea. How are you doing?
I'm good, thank you.
Great to have you with us this morning. Thank you. Thanks for joining. So you're from Balfour Beatty, massive civil engineering firm, and we want to try and get into their minds of civil engineers. We want to think a bit like civil engineers. And so first question I had for you is, if there weren't any civil engineers, what would our cities look like? Just to give us an idea of what they actually do.
They would look completely different, and if they all disappeared tomorrow, the city would just grind to a halt.
Right.
Nothing would happen.
And why is that?
Because civil engineers are involved in everything from roads to railways to buildings to any form of transportation, but highways, the sewers, the water systems, the tie into electricity and power as well, so everything would just stop.
Right, wow, okay. So a massive influence then on cities, and not just, obviously this is the greater GMEC, the Greater Manchester Engineering Challenge, but we're not just talking about Manchester here, it's much broader than that. I mean, Balfour Beatty works on projects right across the country, is that right?
Across the world.
Across the world, apologies.
We're an international company.
Right,
yeah.
okay. Oh. Okay, and so civil engineers are having that impact and working on those projects right across the world. So I suppose I'm just trying to think. This morning, so far, I've brushed my teeth. The water then would have been delivered through civil engineering systems. I'm using electricity. We're connected via electricity, and they've influenced that as well. Yeah. So really, it's massive.
So to get in your car and to drive to somewhere, to a supermarket, you need that infrastructure to be there, or even to walk the dog down the pavement. There needs to be a pavement in the first place.
Yeah.
So,
and that's civil engineers. Right, okay. So you really can't understate or overstate rather, the magnitude of the role of civil engineers. So, but that's the kind of stuff that challenges they've already kind of tackled and stuff. What are the challenges of the future? Are there sort of new challenges for civil engineers to be tackling? What's Balfour Beatty doing at the moment?
Constant challenges, climate change, flooding. Okay. We're responsible for obviously maintaining certain assets that we've created. We're in the process of, obviously, there's massive infrastructure projects that are happening across the world. Big rail projects that are happening in the UK. Tunnels, bridges, maintaining and adding to habitats of animals. If anybody watched Country File that was on last night, they were talking about all that, moving the species and taking down habitats of areas. That all has to be considered, and civil engineers play a part in that, because they need to understand what is currently in the ground at the moment and what that ground needs to look like and what it needs to do to then allow us to put that infrastructure in place on such projects like big rail or road schemes.
Yeah, because actually we were chatting to Alison Watson, who was a land surveyor and worked with Geospatial engineers, and she's talking about how it's really important to understand actually what is there before you start your projects, and that extends to the animals or the natural environment and looking at the impact. Is that the case?
Absolutely. Yeah, definitely.
And I know
some of these habitats have been there for hundreds and hundreds of years, so they've got to be maintained, where possible. And where they can't, controversially, they need to be re-established, and something else needs to be put in place. But you can't underestimate nature. So if you don't understand what's happening underneath, then you're going to get flooding, you're going to get corrosion, you're going to get landslides potentially, and all sorts of things. So that's the role of a civil engineer. Yeah,
I was about to say that. So bringing it back to what, trying to get into the mind of civil engineers, they need to consider all of these variables, all of these possibilities. And so they really need a broad, it's a really interesting role, because there's so many different elements to it.
Absolutely, yeah. They shape the world, to be honest. That's how I would put it. So.
Right, I love it. Yeah, shape the world. And I know that within your work within Balfour Beatty as well, that you highlight, all of the opportunities for jobs, because you work with people in the local area to big construction projects. Just tell us a little bit about that as well.
So when we start on a big project, we're successful, we win a big project, a hospital, for instance, or working, you mentioned the University of Manchester. We've just built a £400 million engineering campus for the University of Manchester, just off Oxford Road in Manchester. 5 engineering schools coming together under one state-of-the-art building. So while we're there, the University of Manchester have said, well, while you're constructing that building, we want you to have a positive impact on that local community. How many local people can work on that project and benefit from it? You know, how many schools and colleges can you get involved in, like today, and demonstrate what kind of roles and careers are available in an industry that, you know, that Balfour Beatty works in. And £400 million engineering campus, you can't get much bigger than that. It's
incredible.
The biggest higher education construction project in the whole of the UK. And it's going to plan, and hopefully it should be finished and handed over to the uni end of next month. Sorry, not next week.
You might give a few people a bit of a start if you bring their deadline forward like that.
4 years has been a long time, so we're getting there now.
Right, so it's amazing to hear of, you know, there's just obviously so many opportunities out there as civil engineers for young people taking part in GMEC that might think that they are interested in pursuing a career in this. And within civil engineering, such a range of problems to solve, things to get curious about. And I wanted to mention to you, actually, I used to be an aerospace engineer, so I love aeroplanes. And one of the projects that I understand in the pipeline kind of challenges of tomorrow is to try and reduce the impact of airports on cities, and one, you know, with the noise pollution of aircraft travelling over cities. And one of the suggestions is to have circular runways, which I think is So you'd have to design planes slightly differently, but you could get them to take off in like a circular loop. So I guess, whilst the aerospace engineers would be tackling the challenges associated with that from the aircraft point of view, it would be the civil engineers who say, right, how on earth are we going to build a circular runway? Is that the case?
Absolutely, 100%.
Right.
Yeah.
So
they'd be all over that. I imagine it being some sort of like multi-story car park kind of thing, like with those ramps. That's all I can envisage. But yes, there'll be some civil engineers that would be delighted at the opportunity to try and look at that.
So maybe I'll see you working on one of those challenges in the future, maybe.
Yeah, possibly.
Yeah. So, well, thanks so much for joining us and sharing about that. And just quickly, I mean, you've kind of touched on this a little bit already, but why did Balfour Beatty want to get involved in GMEC? I mean, I guess it's for the same reasons a little bit we've talked about, all the opportunities here, but just share with us a little bit on that.
Well, an opportunity to speak to young people, to give them an insight into the roles that are available. You know, they look at a big, dirty construction site and think that the 800 people on there all work for Balfour Beatty. They don't, but there's key individuals on that project that do. And we need engineers and civil engineers, and we need new people to join the industry. We need tech-savvy young people to come in with their ideas and make an impact in organisations like ours. So why not? You know, we were working for the University of Manchester. They've given us an opportunity to get involved, and I think it's something we'll stay involved in.
Fantastic. Yeah. Well, thanks so much for joining. There we go. Everyone out there that's watching, please pursue your interest in civil engineering so you can build me a circular runway. I look forward to taking off on that. Thanks so much, Andrea, for joining us. I'll say cheerio, and we'll crack on with the task this morning. Bye now. Okay, welcome back. So I'm sure that you found that really interesting to hear from Andrea a little bit more about what civil engineers actually do. Now, in your task, I've got details of the tasks that you're going to be tackling in GMEC. You are going to be designing your own community space. So you're going to imagine that you're the designer, you're the civil engineer, and you're going to think about who would you want to live with you? What would your houses look like? What kind of facilities would you want to have in your community? So a park, a bicycle track, etc. Now, the first thing that we're going to do is we're actually going to use Google Earth so that we can find our school and we can go for a bit of a virtual walk around it. Because it's really important that surveyors, before they before civil engineers start to think about a new project, they need to work with people called surveyors, land surveyors and geospatial engineers It's a big title, that is. We'll learn more about that in a second. To actually look really closely at the area that they're actually going to work on it with a new project, to see what's already there, look at the landscape, look at any existing buildings, look to check if they're going to potentially influence any habitats there. And I think that Andrea was talking briefly about that before as well. So we're going to use Google Earth to have a close look at our environment. Let me just quickly show you Google Earth. It's really cool if you haven't used it before. It's free and online. All you need to do is Google Earth and click the first link that appears, and it will take you to Google Earth here. Now, this is fantastic. I love the fact that somebody in a meeting at some point at the Google offices said, I know what we'll do as a new project. Let's photograph the whole of the Earth. Oh, and someone went, yeah, what a great idea. And I'm pleased they did, because this really is a super tool. What you can do here is you can put in the address of, or the postcode of your school. And when there you go, see my school, Crumpsall Lane. When I hit return, ready? Watch the zoom. Here we go. In we go. How cool is that? And there we go. We zoom the whole way in. Now, when you first arrive in Google Earth like this, it uses a 3D. It gives you a 3D sort of profile. And it's really clever how it does this. It actually uses machine learning and artificial intelligence to turn the aerial view of the map into more of a three-dimensional view. If you want to then go to 2D view, you can click on 2D here, okay, and it will take it back to being 2D, a bird's eye view as you look above. And then you can also rotate where north is by clicking on this compass down here as well. And you can even then do street view, where you click on the little icon down here and you plonk your little man there, little orange cartoon figure, onto the street, and you can go right in, and then you can go for a wander along the street. So there is my school where I teach my year 5 and 6 pupils. So Google Earth is it's a superb tool to use for this activity and other activities as well, when you want to have a look at various local areas. So let me just show you that again. We can come out of Street View back to the overhead view. I can double click here and then make that north again. There we go. So let me just show you that again. You just simply click on the magnifying glass, you put in your postcode there, it will zoom you right in, and then you can move around looking at your local area to your school, and you can go between 3D, which I must say is a very cool view, and 2D, and then by clicking on this little cartoon person here, you can go into Street View. Now, this is so this is the tool that we're going to use today. Let me just come out of that a second and come back to me here. But we need to be thinking about, well, what actually is it when we come to look at our local area before we do our project of designing our community space? What are we looking for? So what do these land surveyors and geospatial engineers, what do they look for? Well, I know. Why don't we speak to one? That would be a good idea, because they know more than I do. So now, earlier today as well, I caught up with Alison Watson, who used to be a land surveyor and is now the CEO of Class of Your Own, an organisation which champions getting young people into engineering, civil engineering jobs and careers. And she talked to me about what these geospatial engineers are exactly, what are they looking for. And some top tips which she could give you on when you come to do your desk survey, so looking at your local area, what you should be looking for as well. So let's go to that interview now, and I'll see you again in a few seconds. Hello, how are you doing, Alison?
I'm very well, John, thank you. How are you?
Yeah, I'm good, thank you. Great to see you, and thanks so much for joining us to talk a little bit about civil engineering and engineering more broadly. So first question I'm going to have to ask, so what actually is a geospatial engineer?
Well, geospatial, well, first of all, we're all about looking at the land, the form. If I think about things like distance, direction or orientation, and also elevation of man-made and natural features of the land. So when you look around you, when you go outside, you probably don't think about it. Everything has a position in time, and everything has a position on the earth. So geospatial engineering and surveying is all around making sure that we connect those different things, all the things that you see around you. And if we think about geospatial engineers particularly, they're involved with major projects. So things like roads, bridges, tunnels, so your big motorways. These girls and boys get involved in lots and lots of those big industrial projects. Okay. So they absolutely need to know where everything is, where the position of everything is. If you're going to put a new bridge in, obviously you need to know it's going from A to B and what's around A to B to make sure it's in the right place and it works properly.
So I'm sure in the past when I've seen sort of big construction sites, engineering sites, you see people with a sort of tripod type piece, I was going to say machine, apparatus, equipment, sort of measuring through it. Are those geospatial engineers? Are they measuring the elevation? Did you say the height?
Yeah, absolutely. So we have specialist equipment. So those things that you see on three legs, they're not TV cameras, as they often used to be mistaken. They are called total stations. There's also GPS. Yep. And obviously for GPS, just like you have in a car or when you're walking around with your iPhone, as surveyors and engineers, we also use satellites in the sky to make sure we have accurate positioning. So on really, really big jobs, we might use GPS. On small jobs, we can use GPS. But we also use things called total stations, which basically fire out lasers. They're very, very cool kit. It's cool technology, so you get to play with lasers. But they're basically measuring angles and distances. So really, it's just good old-fashioned maths and really, really easy maths that every child can understand. So,
bit of Pythagoras.
Like be a surveyor or an engineer.
Yeah, fantastic. And so when geospatial engineers, land surveyors are on these sites and they are sort of analysing them in preparation for design and construction, what are the three sort of main questions that they're looking to answer? If we try and get ourselves into the mindset of these engineers, what questions are they asking themselves that they want to answer about these sites?
Well, I'm a land surveyor and I work very, very closely with geospatial engineers. We're all sort of a family. We're all about, where things are. So the first thing, I'll not use any equipment. I'll use my feet and my eyes. They're the most important tools that a surveyor and an engineer can have. So when we first get onto a site, and whether we're going to look at something for housing or a new road, we need to use our eyes and see what's around us. Where are the obstacles? Where are the things that are going to be challenges? Where are the things that may be dangerous? Because, even when you look out on the road, you probably don't realise that underneath your feet, there's lots of cables. So electricity, things like your broadband, things like water, your drains, they're all under the roads. And without your eyes, you don't really see them. And I suppose really you need to be thinking about what are the clues, because it's almost been like a detective. Sure. What are the clues that are going to tell us what's under the ground? Because as you can imagine, if we're going to excavate, that means if we're going to dig under the ground to move the ground away to make a new road, we could be cutting through some fairly dangerous things. Yeah. You don't want to be cutting through an electricity cable. So one of the first important thing is use your eyes and look around. So in terms of things that I look out for, I will be looking out for things like existing buildings. So what's already there? Because obviously if I'm going to design a road, as a geospatial engineer, I need to make sure that road's not going to come through the middle of your house. And I'm sure, John, as you're start teaching your breakfast, the last thing you want is a digger piling through your kitchen.
I'd rather not.
Exactly. So existing buildings that are already there are really, really important. You think so natural and man-made features. So obviously a building is man-made, existing roads are man-made. And then we think about things like natural features. So trees are very important. We all love trees. We want to protect trees. And obviously, we don't want to be chopping trees down to make way for our new roads. And we have to be very, very careful to get the balance right, because some trees are protected by law.
Okay.
And there's an enormous fine that you can be charged if you actually chop down a tree. So the things that I'm looking for that are most important are what are the natural features, how does the land change in height. So if you imagine everything from a mountain to a tree, a building, a curb, even the curbs that go along the edge of the roads. If you imagine from the road to the footpath, there's a slight change in height. It's only about that big. But that's all changes in height. So we look at all those different things, all those different features, so that we can produce an accurate map, so that when the people who design cities or design buildings or design roads and bridges and so on know the changes in height and the different man-made and natural features that are going to get in the way or indeed be part of that new landscape.
Fantastic. Okay, right. Well, I've learned so much there about what the role entails and what you're actually looking for. And I think it's that looking, isn't it? That's what I'm getting from you. You keep saying use your eyes, and that is exactly what we're going to be doing in the task today. Shortly, we're going to be using our eyes, looking, not just looking, but really looking and noting down what we see in our own community and area. So thank you so much for explaining that. We'll go back to looking at what the task is for our pupils today then. Okay, I hope you took all of that in. Some fabulous information there on the role of geospatial engineers from Alison Watson. I learnt lots there, and I was really intrigued to finally learn what those tripod things are, bits of equipment that I have seen on civil engineering sites and how they're used. Now it's over to you for your task as part of this lesson today, this GMEC lesson. You are going to conduct a desk study. So you're going to use Google Earth, which I've already shown you, and you can rewind if you need a recap on that. And then you're going to use the resource that we have produced for you, and you should be able to see under the iPad if I click on, there we go, you should be able to see me and this resource here. So what we've done is we've produced a resource to help you looking closely at your local space. So we have here the various features that you might look for, and then what is there? List what you see, but then what do you observe? Look really closely. Okay, so as Alison was saying, it's all about looking, and sometimes we can be a little bit oblivious, which means not really noticing when we're looking. We just think we're looking, but we're not really looking very closely. So let me start and have a go at this. So let's go back to my Google Earth, and I think I'm going to go 3D, and then I can scan around on the map as well. So first of all, commercial buildings, shops, superstores. Let me come back and show you where I'm looking on here. Here it is, shops, superstores, restaurants, post office, cinemas. Do I see any of those in my local area? Well, actually, I know this local area quite well. If I spin round a little bit, this, and I zoom in, isn't this fantastic? This street here does actually have a few commercial buildings on it. Can you see? If I swing round like this, these are actually all shops underneath the houses there. And actually, I think it's that one is a post office. Okay, I could check that by going for a bit of a walk on this street. Let's jump straight into here. How cool is that? And yes, look, there we go. That is the post office. So let's maybe start filling this sheet in. What is there? There's a post office. Let's go for that one to start with. I'm sorry about my poor handwriting. And what do you observe? What do you really see? Well, it's one thing that's interesting is that it's part of a building which also contains flats above. So part of, now we can call this a residential building, and actually that's the second thing on our sheet here that we're going to look out for. So it's part of a residential building, because that's an interesting observation. It's not just a post office on its own, or it's not built into a supermarket or something like that. It's actually part of a residential building. What else can we look at? Let's go back to our map here. Let's come out of Street View. Or actually, no, even better, let's go back to Street View and go for a walk down this road. Here we go, in we go. So we've got things like takeaways, Freddy's. These are commercial buildings as well. A little bit later on in the sheet, it asks us for things like communal buildings as well. And I think I spotted, if I remember rightly, if we turn around and go back this way, here we go. Yes, this is a church that's on the corner here, so that's an example of a community building. Let me just go one more and look around this way. Yeah, that's the Methodist Church for Crumpsall. And if I actually come out of that and then go along this way here, still in the local area, we've got another church here, which we can go and have a look at. That's St Matthew's Church. So there we go. I can have a look and then going for a walk around the local area, and then importantly on my sheet I can fill in the information which shows I've really looked closely at what is there in the local area and how that actually looks, any unique features of those features that you are seeing in the local area as well. So make that as comprehensive as you can to show that you are really looking carefully. Now let me remove that one. So that's your first activity. And then your second activity is about abstracting the key features. Now, anybody that watches any of the computing videos that I've done will hear me talking about abstraction, because abstraction is all about focusing on what's important, the key features, and forgetting the rest. So, really lovely activity, this one. It says, what are the key features in your area? Describe in just a 30-second pitch what are the best and worst things about your area. Pick out 3 good things and 3 improvements you think it could be made. And you can present this however you like. You could be creative with a poster, a video, a letter, whatever works for you. So that's the second activity that you can do for this lesson today as well. So there we go. We've learnt loads about civil engineers in this session this morning. I'm saying this morning, you might be watching it in an afternoon, but it's been packed full of information to help us start to get into the mind of being a civil engineer, which is really important, because by taking part in this project, you are going to start on your journey to thinking like a civil engineer. So I will see you next time, and I hope you have fun doing these engaging activities. Bye for now.